In this video, we will talk about some very important points related to Merchant Navy ships which are being asked during the interview as general knowledge. As I told you in our previous video, that these are very big ships and they float and move in the water. So the question is, how such big ships float in the water? Guys, the basic theory behind the flotation of these ships and their construction is Archimedes' principle. You must have studied this Archimedes' principle in class 10th. That is why you should be very thorough in Archimedes' principle so that you can answer any question related to this topic in the interview without any mistake. This topic is very important. So let's quickly talk about Archimedes' principle. So as you know, if we put a body in a liquid, the body displaces the liquid and the volume of the displaced liquid is equal to the volume of the immersed volume of the body. This displaced liquid pushes the body up with a force. This force is called buoyancy force, and the magnitude of the buoyancy force is equal to the weight of the displaced liquid. So now as soon as we put a body in the liquid, there are two forces acting on the body. Number one, the weight of the body which is downward, and the buoyancy force which is acting upward on the body. So if the weight of the body is more than the buoyancy force, then the body will sink in the liquid. And if the buoyancy force is more, then body will float in the liquid. Based on this principle only, the ships of Merchant Navy are designed. They are made hollow from the inside so that the amount of water displaced by them is much more than their weight. So the weight of the water which these ships displace is much more than the weight of the ship. That is why we can load some cargo on the ship so that the weight of the ship plus the weight of the cargo is also less than the weight of the water displaced by the ship. So when the ship is sailing in the sea, the weight of the ship and the weight of the cargo which is loaded on the ship is equal to the weight of the water displaced by the ship. That is why the ship keeps floating while it is sailing. If you want to load more cargo, you can load, and the ship can compensate it easily by sitting lower in the water. This way, by sitting lower, it will displace more water, so the buoyancy force will also increase. So you can load more cargo and the ship can easily compensate it, but there is a limit for it. If you load beyond the limit, the ship will sink, because at that time the buoyancy force will become less and the weight of the ship and the loaded cargo will be much more. So the ship will sink. After understanding Archimedes' principle, let's see some important points about the ship. Guys, as you can see in the image, these big ships move in the water and carry cargo. In the forward part of the ship, cargo is carried, and this cargo is in the range of 3 lakh to 4 lakh tons. You can imagine how big these ships are. A truck which runs on road that carries only 20 tons of cargo, but these ships, they carry 3 lakh to 4 lakh tons of cargo. To move these ships in the water, there is a propeller. This propeller is fitted behind the ship. So when this propeller turns, it pushes the water, and with this thrust, ship starts moving forward. Guys, these are very big propellers. So when the propeller turns, ship moves forward. And if we want ship to move backwards, then we have to turn the propeller in the opposite direction. So ship moves forward and backward with the thrust generated by the propeller. And to move the ship or turn the ship to the right side or left side, we use rudder. This rudder is fitted near the propeller. So this is how, with the help of propeller, ship moves forward and backward, and with the help of rudder, it turns towards the right or left. Here the question is how we apply brakes on the ship. Guys, there are no brakes in the ship. That is why controlling a ship is very difficult task. In the absence of brakes, you have to be very smart to control the ship. The only braking arrangement you can do is with the help of the propeller. So if the ship is moving forward and you want to apply brakes, you can turn the propeller in the opposite direction. So the propeller will try to move the ship backward, and that is how brakes will be applied. But guys, these brakes are not that effective. Okay, so when the ship moves in the sea, the distance covered by the ship is measured in nautical miles. 1 nautical mile is equal to 1.852 kilometers. Generally, the speed of a ship is 10 to 15 knots per hour, which is approximately 25 to 30 kilometers per hour. So when these ships sail in the sea, to locate these ships, latitudes and longitudes are used. You must have studied latitudes and longitudes in the geography in class 8th. First thing you need to know is equator. Equator is an imaginary line drawn on the earth at the center, equidistant from the both poles, North Pole and South Pole. And the latitude is a measurement on a globe of a location north or south of the equator. The latitude is given in degrees, minutes and seconds. And the imaginary vertical lines that run from the North Pole to the South Pole on the map are called longitudinal lines. For the reference purpose, the prime meridian is taken as 0 degrees. So, the prime meridian is the longitudinal line that has a value of 0 degrees. The prime meridian is also called as Greenwich meridian. So, the angular distance of a place east or west of the Greenwich meridian is called longitude, and it is expressed in degrees and minutes. So this is how to know the exact location of the ship. We use latitude and longitude. Another very important role of longitudes is to determine the local time of a particular place. As you know, the merchant navy ships, they travel around the world, so their local time keeps changing. It is not constant. As the ship travels from one place to another place, its local time keeps changing. Guys, you must have studied in geography that the time at Greenwich line, which is 0 degree longitude passing through Greenwich near London, is considered as the standard time. As you know, there are total 360 longitudes, and the time difference between each longitude is 4 minutes. So, we take Greenwich time as reference and then we calculate the time of all other longitudes. Greenwich time is called GMT, Greenwich Mean Time, and this is the standard time accepted internationally, and the time of all other time zones is calculated according to GMT. So as I told you, the time difference between each longitude is 4 minutes. So if it is 12 o'clock noon at Greenwich, it would be 12 o'clock and 4 minutes PM at 1 degree meridian or longitude. You must be knowing, in India the standard longitude to calculate the time is 82.5 degree. So the time difference between Greenwich time and India is 82.5 into 4 minutes, which is equal to 330 minutes, or you can say 5.5 hours. So India time is Greenwich time plus 5.5 hours. It means if the local time at Greenwich is 12 o'clock afternoon, then the time in India is 5:30 PM. So by now you must have understood that as the ships they keep on traveling around the world, their time zone keeps on changing. So which time ships should follow? That is why generally all the ships follow GMT time.